Cool, so I'm going to be doing a quick talk on 3D printing. So I'm a third year Masters of Computer Science student. I'm head of engineering at Warwick AI, and kind of one of my hobbies is web development, but I'm also obviously interested in 3D printing. That's why I'm doing this talk. So I got my family got our first 3D printer. It's that printer there in 2015, which is kind of towards the start of the hype of the 3D printing. It's based off a Prusa i3 design, but it's kind of a Chinese copy. But it's still going strong. I've got it at home at the moment using it. I also then fundraised and set up our school's first 3D printer. And as a small school, it was quite a big thing for our product design department to have our own 3D printer. And also during the first COVID pandemic, first COVID wave, I also worked with a team called 3D Crowd, who gathered thousands of 3D printers around the UK to make face shields. So I printed over about 60 of these components for face shields. So to start off, what is 3D printing? Now, over recent years, people kind of associated it with this kind of one 3D printer design, but it's a lot more general what 3D printing is. And the idea of 3D printing is it's just to create a 3D object via an additive manufacturing process, so not removing material, just adding material, and from a digital specification or model, so something like a CAD file or some machine code instructions. That's typically how it's done. So now you kind of know what the basic idea of 3D printing is. We'll go a bit through the history. So the first kind of 3D printer concept was developed in 1981. It was an SLA machine, which is basically where you've got resin and you cure the resin with a UV light. And then a company took this idea on and released the first commercially available machine called the SLA1 in 1988. In that same year, a patent was filed for another form of 3D printing called SLS, which is where you've got powdered metal, and with a laser, you kind of do loads of little welds to produce a 3D part, and then you layer it up. Then in 1989, a patent was filed for FDM printing, which is kind of the standard, most well-known 3D printing method that you're probably familiar with. And then between 1989 and 2005, 3D printers were mostly used commercially, often as rapid prototyping machines, so not really for final parts for anything, and more just internally to develop models. And then in 2005, the RepRap initiative was started, and the whole idea with RepRap was to create a 3D printer that could print another machine, so print parts of another machine or the complete machine, and also print other stuff. And that, combined with the patents for FDM expiring in 2009, this whole kind of the modern day 3D printing revolution kind of started. And then between 2009 and 2015, printers became cheaper, components got cheaper, standards were starting to be introduced. And then Prusa, which is probably one of the most well-known 3D printer companies, released in 2015 their standard i3 Prusa design, which is what a lot of 3D printers are based off. The 3D printer I've got at home, you can kind of tell it's kind of this similar box shape, and the design is still kind of used today as the standard. So I'm going to go quickly through different types of 3D printers. There's kind of 4 types that are seen. The first one is the standard FDM, or filament deposition modeling. So the idea of FDM is you've got a real filament, and then you work from the bottom up, kind of laying down layers of plastic. So you build up layers, and you can often see the layers as well when you do FDM printing, because it kind of squishes the layers on top of each other to build a 3D model. Now, the advantages of this is it's very simple in comparison to the other methods, which you'll see in a minute. It's also quite low cost, both initial cost and material cost. And also it's very safe to use. The only real dangerous part is the hot end, which is usually over 200 degrees. But as long as you don't touch that, there's not much that can go wrong. The issue with it is because you're printing layers and you've got to physically, manually move a hot end around to lay the material, it's quite slow. And the speed of your prints scale with the volume. So you can imagine if you increase the size of your model by 2 times, your volume increases 8 times. So then your 3D printing time takes 8 times longer. And also your resolution, so how fine of details you can do, is typically limited to the hole in your nozzle, to the hole diameter. And that's a trade-off. If you make the hole smaller, you have to print slower because you can't push as much filament through. But then when it's bigger, you lose the resolution. So your minimal thickness of material you can extrude out gets higher. So you can't be as finely detailed. On the other end of the spectrum, there's SLS, which is selective laser sintering. So this involves a fine powder. Typically it's metal, you can sometimes do plastic, and it will be spread across a bed. A laser with mirror will direct a laser around to kind of weld parts of the powder together to form a shape. And then it will put another layer of powder, do the same. So it's kind of, again, this layering up process, but now instead of extruding material, it's welding material. Now you get very, very good print quality with this because your resolution is no longer determined by the nozzle size, it's more determined by how finely you can move the laser. It produces very strong parts. This is kind of down to being able to produce metal parts, whereas you can't really extrude metal out of a 3D printer, or like a standard 3D printer. But the issue is it's quite messy, so the powder isn't very nice to deal with. It's very fine, so it's almost like dust. And it's not for consumers at all. It's very, very expensive. So these machines can easily cost 100 to 1,000 times more than an FDM. And they're typically used in industrial applications, but they tend to be used, they can be used more for final parts in a mechanical assembly. Whereas a lot of time FDM printers are more just used for fun models or you don't need to depend on the part as much. Then the third type of 3D printer is SLA, which is curing resin with UV light by moving the UV light with the mirror. So similar to SLS with the mirror, but now it's UV light and you've got resin, so a liquid material. Again, you're limited by resolution by how fine you can move the UV light, so it's got quite good resolution. And really good print quality too, because of that high resolution. But the issue is resin, especially uncured, can be very dangerous. So, because it's got fumes, so if you inhale it, you can easily get an allergic reaction to it. You've got to wear gloves when you're handling it. And when you take prints out of the machine, they're not necessarily fully cured. So there's the danger there, even once the print's finished, of being harmed by the material. And also they're slightly more expensive than FDM. They're coming down in price over recent years. The craze that happened with FDM has happened with SLA, in that a lot of the companies that made really good FDM printers, like Prusa, have now made SLA printers. So the prices come down, but they're still more expensive. The final printer type is DLP, which is kind of similar to SLA in that instead of moving a UV light around with a mirror, you can kind of think of it as a screen, and the screen will flash with light with a trace of where it wants to cure the resin. So you think if the resin is above the screen, and then wherever the screen is lit up, it will cure that shape in the resin to that layer, and then the layer will pull off, and then it'll do it again for the next layer. So again, it's got kind of the same qualities as SLA, great resolution, amazing print quality, and it's got one more advantage of it's a constant time per layer. So no matter how much you want to cure on one layer, it'll take the same amount of time between prints. And that's because you're no longer having to move something around. You just flash the light, so you kind of just display what you want on the screen, what you want to cure. So there's no mechanical moving parts. And that's another thing. The only mechanical part on these is lifting the bed up and down. So there's a lot less to go wrong. And that's kind of the standard. People kind of mix up SLA and DLP. DLP is kind of the cheaper version of SLA a lot of the time, just because it's easier to make and maintain. But again, resin can be dangerous, and it's slightly more expensive than FDM. So moving on to the different type of materials that you can print with. So as I mentioned earlier, FDM uses plastic filament, and it typically comes in diameter of 1.75 to 3 millimeters, depending on the printer. So most if you go and buy a printer, it'll be 1.75 millimeters. And yeah, so what they do is they get pellets of plastic and then they just extrude it into a long kind of filament spool. And typically these spools come in like 1 kilo spools. So because the requirements of the 3D printing with filament, all it needs is to be able to have a filament that can maintain its kind of integrity and storage. And as long as it can be melted at a reasonable temperature, you can basically use whatever material you want. So the most popular one is PLA, polylactic acid, which is a based off it's a natural kind of occurring material. Then there's also ABS, which is a bit stronger, and also PCG, which is even stronger. And then you can also print with stuff like chocolate. So they've made chocolate infused plastic to make kind of have the scent of chocolate. But people have modded their machines to actually print with chocolate filament. Typically, it's not via filament then. It's like a hopper design with just the chocolate melting and running through. But yeah, with FDM printers, there's so many different materials out there. Recycled materials, like metal infused materials to make it stronger, woods chipped infused materials to make it look like wood. There's so many. So as I mentioned, PLA is natural, so you can actually get food safe prints out of an FDM printer. And also it's the cheapest out of all the options at roughly £25 for a good roll of FDM filament. The quality varies with how the tolerance is on the diameter of the plastic. If your tolerances are not as good, you can get bad prints where you get layers splitting apart because it's not pushing out as much plastic, or you can get clogs in your hot end because it's too much plastic going through. So the other material is resin, which is used in SLA and DLP. So it's like a liquid form material. Now the issues with resin is as I said earlier, it's harmful until cured. It's got fumes associated with it. And also it's more expensive at about £100 per litre. Now you can roughly a litre of resin will print about the same amount of stuff as filament, like a kilo of filament. You can't really make a one-to-one comparison because you're typically printing in different ways, but it's kind of the same price, amount of plastic you use. Also, it's sensitive to storage conditions because it's cured with UV light. If you just put it in a translucent container, it would just cure over time, and you've just turned it into a solid plastic bottle. So you have to store it in opaque bottles like that. Then the third material, which is this isn't really available to consumers because it's used more in industry, is sintering powder, and this is used for the SLS machines. So you can see it's fine material. It's safer to handle than resin. It's still very fine stuff, so you don't really want to inhale it or touch it with bare hands, but it is safer. But it's even more expensive than resin because it's not just, they haven't just made, it's got other stuff in it to make the sintering process better, and it's metal, which metal is going to be more expensive than plastic as well. And also it gets everywhere. It's not very practical to use. So that's another reason why you don't really see it being used in home workshops. It's more used in big companies to make actual parts for a product, or stuff it's like Formula One uses SLS to print parts for their cars. Same with aerospace engineering also uses SLS. So I'm going to kind of talk a bit about the 3D printing process. So you start off with a model. So this is kind of either be a model that's already been made from Thingiverse, which is like a massive repository of 3D models. They've basically got everything on there. Or you can make your own in the CAD software like Fusion 360. And you want to export that model format into a format called STL, which is a triangular mesh that's kind of used, it's the standard within industry. So yeah, you're converting your kind of geometric representation of your models into a triangular mesh. Then you send this model over to a slicer. So an example is Prusa Slicer. And what this software does is it converts your mesh into G-code. G-code is a kind of machine instruction code that you run on not just 3D printers, on CNC machines as well, on laser cutters. So yeah, G-code is just instructions to send to the printer. And what it'll do is, the reason why it's called a slicer is it'll split your model into slices of layers. So you specify how big you want each layer to be, and then it'll say for this layer, draw this path. For the next layer, draw this path, and then also instructions like heating up the filament, putting the fans on, finishing the print, stuff like that. And when you slice as well, you'll also be told things like the print time and how much filament it approximates you'll use, which is quite useful to know if you've got enough left on your roll for it to finish the print. And in the slicer as well, you can specify if you want to print multiple materials, you do that in your slicer. So you can say this area here or this part here wants to be a different color. So if you've got a printer that can print in multiple materials, multiple colors, you'd specify that in your slicer. Then the final step is to print. So obviously you need to load your file into the printer and you print the model. Some printers require extra steps after finishing the print. So with SLA, because it's resin, the prints aren't fully cured after they come out the prints. They're structurally stable, but you want to cure them fully. So what you typically do is either put it out in the sun, or people have made, there's products out there that are like UV light boxes that'll spin the part and make sure it's all cured properly. Yeah, so that's kind of why FDM is kind of still the most popular, because it's you print it, and as soon as it prints, it's basically ready to go. You don't need to do much afterwards. You can sand away the layers or like use acetone to kind of melt the layers so you can't see each individual layer. But I never have. Usually the print's good enough quality straight off printing. So how can UWCS help you with 3D printing? So they have this machine here, which is a Prusa i3 Mark IIs, which is just an upgraded version of the original Prusa one I showed you earlier. They've also upgraded it themselves with a multi-material support, which allows you to have multiple filaments being used in the same print. I think it's 5. You can print up to 5 different in the same print. So you can actually print with different materials. So if you've got support material to like support an overhang, you can print that in PVA filament, which means it can dissolve in water. There's cool tricks you can do like that. A lot of time people just use it to print with different colors. And then, yeah, so if you want to print, send an email to that email there. It'll notify the exec you need to know. I don't think it's set up at the moment, but it is being planned to be set up soon. So it's currently not really got a home where it can be used, but when it is, yeah. And it's free if you are a member to use. Obviously, if you're printing large batches or a big model, the filament you can start to get quite expensive with the filament costs. So they do expect a contribution towards that for large prints. But yeah, other than that, there's a printer available to use. I know engineering department as well. I think anybody in the uni's got access to that. Or if you've got an engineering friend, you can just kind of ask them to go and print something for you. Cool, thank you very much.